Hello, I'm Jose, the Powertrain lead for Accumulator 2. First thing, I would like to shout out every member of the team for their hard work this quarter. With the ongoing pandemic and limited lab access, we have done plenty of design iterations in order to comply with the 2021 FSA competition rules, machining limitations, as well as ensuring that the powertrain components do not interfere with other subsystems in the race car. We start off with the motor control enclosure assembly. With the motor control enclosure, the design was modified as a rectangular shaped box for ease of manufacturing and assembling. The design of the enclosure is water resistant and meets the requirements from the FSA competition rules. In addition, the mounting tabs were analyzed structurally to determine whether or not the weight of the enclosure with the installed motor controllers would cause the tabs to yield. Ultimately, based on the FEA, the maximum stress on the tabs is 6.4 megapascals, which is below the yield strength of 204 megapascals. The 3D printed fixture design of the dry flange assembly is implemented to hold the flange and key shaft together prior to manufacturing. This fixture design is the best approach to prevent the shaft from experiencing angular misalignment and allowing both rear wheels to receive mechanical power with minimal energy loss. By inserting the shaft inside of the center hole of the flange, the fixture will keep both components rigid and provide accessibility to weld both components together without melting the 3D printed fixtures. As far as the chain guard was manufactured to meet the dimensions prior to bending. After carefully verifying the FSA 2021 competition rules, the manufactured chain guard was not rules compliant because the material was originally aluminum 6061 T6. According to the FSA 2021 competition rules, for a race car that is powered with a chain driveline, the material of the chain guard must be steel. In conclusion, since all revisions to the powertrain components have been finalized, the components such as the motor control enclosure, drive flange, and chain guard have been approved to be sent out to be machined with the appropriate material and dimensions. The plan during winter quarters to continue with the manufactured process for the presented components, receive data from testing Accumulator 1, and begin integrating all powertrain components into the Accumulator 2 chassis. Thank you.
Hello, my name is Mark Takahana, and I'm the sub-team lead for batteries on Anteater Electric Racing. First, before I begin, I'd like to give a shout out to all of my team members who worked very hard to make it all happen this quarter. Our first component here is the accumulator container, which houses the high voltage battery as well as its supporting hardware, such as the thermal management system and battery management system. This quarter, we put together the internal frame, which you can see in figure 2, and now it is ready to have its walls bolted on. Next, we have the accumulator handcart. Due to the rules, we have to have a safety handcart to transport the battery to and from the charging station. First, we redesigned some of the handcart as to recycle some parts that we already had in the lab, and then we assembled the handcart frame. Next, mounting. Most of the time that we spent on mounting, we spent on verifying a 15 kilonewton load in any direction, which is required by the rules. At this point, we have test mounts machined, and we are currently designing the test fixtures. Next, we have the thermal management system, which is to keep the battery cool. We started out with simulations, which we then turned into a prototype. Afterwards, we rigged up a previous container to act as a test bench, and we have conducted passive thermal management studies, which will serve as a control for next quarter when we run active thermal management tests. Finally, we have our low voltage battery. The low voltage battery is to power the low voltage circuit before the high voltage circuit is energized, and this is a rules requirement. We managed to put this together without any misadventures, which is fortunate. Speaking of which, this quarter has been challenging for many reasons, mostly due to the ongoing pandemic. There were also some issues with parts sourcing. However, when we had the time in lab and also when we had the parts, we were quite productive. Looking into the future, we believe that we can put together our subsystem as well as integrate it within 12 weeks of lab access being restored. Thank you for listening.